Welcome to today's flipped algebra lesson from Chapter 7, Factoring Polynomials. The main unit objective of Chapter 7 is for students to be able to use factoring polynomials to solve real-life problems. These supporting lesson objectives are students will be able to factor x squared plus bx plus c, factor ax squared plus bx plus c, factor the difference of two squares, and factor a perfect square trinomial. The online objective, which will actually be the objective of today's lesson, is for students to be able to use the CPM algebra tiles to aid in solving problems involving factoring polynomials. The supporting online objectives, which are consistent throughout every lesson, are for students to be able to use the video tutorials and live tutor options in their ebook to further their understanding of problems involving factoring polynomials. Today's essential question is, how can you use algebra tiles to factor a polynomial? And a supporting question might be, what exactly is factoring? Factoring is essentially the opposite of multiplying, which was our previous lesson. If you recall, we were asked to do a problem similar to the one you see on your screen. Find the product of x plus 2 times the quantity 2x minus 3. As you can see below here, we have modeled that for you using the CPM algebra tiles with x plus 2 on the left-hand side and 2x minus 3 on the right-hand side. If you recall from that lesson, your job was to fill in the middle area with these supporting algebra tiles to find out the product of x plus 2 times the quantity 2x minus 3. Since that is a review problem, we will jump ahead to the answer. And hopefully you recall that by filling in those tiles, the solution to that would be 2x squared minus x minus 6. Today, what we will do is the opposite. We will start with 2x squared minus x minus 6 on the inside of our algebra mat, and we will be filling in the outside of the mat with the x plus 2 and 2x minus 3. Factor the following polynomial using algebra tiles. As you can see, this trinomial looks like the product of, or the answer to, what we were working with yesterday. Let's go to our CPM algebra tile mat right now. To save time, I have already put the essential tiles on the mat. So we will have an x squared, we will have 6 x's, and we will already have 8 units on our mat. You can see that here. X squared, 6 x's, and 8 individual units. Now, knowing how our solutions all turned out with the multiplication process, you're probably pretty familiar with the fact that the x squared almost always ends up tucked up into this corner. Of course, if there are more x squareds, they would be alongside of them, either below or off to the right. You would also note or recall that each of the x's generally match up with the sides of the x squared because they are the same length, either in this manner here, or if we double click, they turn sideways and would fit down below here. Now, there is quite a bit of guess and check that can go into factoring, but I'm going to suggest to you that the key is in how you want to organize your single units. Now, knowing that all of our solutions in the previous lesson ended up being perfect rectangles in this area, we want to make sure that we do end up with that again. So the key question here is, how can I arrange 8 single units so that they form a perfect rectangle? The first one that came to my mind was a 1 by 8 rectangle, placing all 8 squares side by side, like so. But thinking ahead, I have to recall that I know that the whole thing needs to be a perfect square. So if I put these 8 together and then capture them all together at once and drag them into place, I know that I need to now have a full rectangle filling in these areas here? Well, it looks like I have a good start because these x's look like they're going to slide in. But as you will see here, I eventually run out of x pieces. So have I created a perfect rectangle? No. Is there any way I could take these 3 pieces off and put them anywhere else in this array to make that a perfect rectangle? The answer again is no. So again, how can I rearrange these 8 pieces so that they are still part of a rectangle, but I'm also allowed to fill in the remaining x's? My thought was to go to a 4 by 2. And so I'm going to take these 4 pieces on the end, and I'm going to drag them right here. And I noticed now that I still don't have a perfect rectangle, but if I take this one off the end and I turn it and I put it in right here, what I've done is I have now created a perfect rectangle. So this was our solution in the previous lesson because our outside pieces were already in place. Well, now this is our original problem and we need to put the outside pieces in place. So we're going to match up the algebra tiles from our mat over here with the missing lengths on the side here. I'll start at the top. What piece would match up with x squared? The widthwise is going to be the x. But if you remember, it will take a double click to turn that length. What pieces match up with this unit here, 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 and here? That's where we're going to need the 4 individual units again. Pull those in separately. And thinking ahead down the side, we need our other factor here. What's going to match up with the length of the x squared? Again, that is going to be the x. And what pieces are going to fill in here? Those will be your 2 single units. One thing that you should do is always double check the color of your tile. For instance, as we learned in the math in the multiplication piece, we would take x times x to get x squared, but since both of those are positive, our product also needed to be positive. Remember, if we single click, they do change to negative. We don't want that in this case. As I work my way across that row, I'm going to take x times 1. Both are positive, so my product should be positive, and that will be the case for every one of those, as well as will be the case for this x and those 2 units as well. So it turns out we do have the proper factors in place. Now all we have to do is name them. X plus 4 units would be x plus 4. X plus 2 units would be x plus 2. Jumping back to our presentation, the solution to x squared plus 6x plus 8 is x plus 2 times the quantity x plus 4. This problem looks much the same as the last. Factor the polynomial using algebra tiles, x squared minus 6x plus 8. This will give us an opportunity to take a look at negative tiles. In this case, the only thing different in our problem is the x's are negative. And recall, if we tap on them once, they will change to a negative color of red. So if this was my original problem, and I did that, you see the rectangle is still the same size, so my factors are okay. The only problem is, do my factors actually multiply together to give me those products? For instance, is x times 1 negative x? It is not. In order to have the negative, I've got to have one of the 2 factors be a negative. Would I want to make this x the negative? Negative x times positive x will give me negative x squared, but I do have a positive x squared in my original problem. So I want to change this 1 to a negative. Now you'll see that x times negative 1 is negative x. That will also be the case for each of these 4 single units and these 2 single units down here as well. If you double check your work, you'll have x times x, which is positive x squared. We already checked the x times negative 4 to get negative 4x, x times negative 2 to get negative 2x, and a negative 1 times a negative 1 will always give me positive 1, so negative 4 times negative 2 is positive 8. Flipping back to our presentation, you will see that the factored form of x squared minus 6x plus 8 is x minus 2 times the quantity x minus 4. In conclusion, today's online objective was for students to be able to use CP&M algebra tiles to aid in solving problems involving factoring polynomials. But why did we do that? Think back to our objectives. Our main objective for the whole unit is for you to be able to factor polynomials to solve real-life problems. And the supporting objectives to that are to be able to factor x squared plus bx plus c, which you did today, ax squared plus bx plus c, which is what you will do in the next lesson, and future lessons having you factor the difference of two squares and factor perfect square trinomials. In class tomorrow, your assignment will be to do Exploration 7.5 on page 385, all the while keeping in mind the essential question we did today. How can I use algebra tiles to factor a polynomial?